on section 7.3, and we're going to try to do some graphing of trig with some transformations. So let's go back and review what happens to our parabola, y equals x squared, when we have a number in front and that shift. Well, this shift, because it's in a parenthesis, we're actually going to move it 2 to the right, and this makes it steeper. So we're going to have a graph that looks like that. Same thing is true with the trig. This just means my amplitude is going to go up to 2 and down to -2 because we have no shift up and down yet. And we also have a shift to the left of pi over 2. So if I look at pi over 2, which is going to be this graph. Oh, it's the sign. And we're pushing it to, this is not the graph. Oh, this is the graph of the sine, the original, just like the x squared was there. So this is my sine. We have 0, pi, 2 pi. That's the whole graph of the original. So the graph that I'm looking for is pi over 2 to the left. So over here is where I'm going to put my negative pi over 2. And we know that our period is still going to be at 2 pi. So here, 3 pi over 2 is where that period ends. If we look halfway between there, we know in here is going to be positive pi over 2. Here's 0, here's pi. And so we have the 5 points that we use to graph the sine. So I'm going to put a 0 there. We're at maximum amplitude there. We're coming back down there. We're at minimum amplitude down here. And now we're back to 0. So my graph of the shifted one is going to look like that. So all of these values, whatever they are, just get shifted pi over 2 over. Okay? That's our shift. So when we look at some of the stuff that we need to know, this A out in front here is always going to be your amplitude. Even though it's negative, amplitude is never negative. Never negative. If there's a negative in front of the amplitude number, that means our sine that normally looks like that is going to be the reciprocal of it, so it would do that. So it would go down first and then up instead of up first and then down. That's what the negative A, the negative in front of an A, would do. This part inside here is going to be help us with our period. This B, and I'm going to tell you, I'm going to put it in Mr. Otto standard form. It's going to be very helpful. If I factor out that B, I get x minus c over b. And the b is the number that you divide 2 pi by to get your period for sine and cosine. When you're doing tangent, you take pi divided by b. And this c over b thing that they talk about here is your phase shift, left or right. So when we have a couple examples down here, let's take a look at what's going on. First thing I'm going to do is I'm going to put it in Mr. Otto standard form so I can answer the questions. I'm going to pull out the half, and then I'm going to take pi over 6 divided by a half, which is the same as pi over 6 times 2 over 1, which gives me, looks like pi over 3. 2 pi over 6 is pi over 3. And so we're going to talk about our amplitude is 3. Our period is going to be 2 pi divided by a half, which gives me 4 pi. And then my shift, phase shift, in this case, is going to be pi over 3 to the left. Remember, it's always the opposite direction when it's in a parenthesis. And let's take a look at the second one here. Again, I'm going to put it in Mr. Otto standard form. Pull out that, and I get 2 over pi. Yuck. And so then we're going to say, what's my amplitude? Well, amplitude is the number in front of that cosine, and since there's nothing there, we're going to say 1. Notice the negative in front of there. That's going to tell us that we're going to be reflected over the x-axis. We also know that we have a vertical shift. This guy here tells me I'm moving up 1 for my whole graph. So I basically get my graph and then move it up 1. My period is going to be 2 pi divided by pi, gives me a period of 2. And I have a shift, a phase shift, what we called it over there. Our phase shift is going to be 2 over pi to the right. And we are reflected. I'm going to write that here too. Yes. Because of the negative right there, I know that I'm reflected. Come on. There we go. So we're going to determine an equation for that function. I know it's hard to see what's going on here. This is a 1, this is a 2. And if I want to say, if I start right there, because it's hard to tell where any of these other points are, I'm going to use that. And if we're using that, normally our cosine graph looks like this. Since we're starting on the bottom and going up, I'm going to say it's a negative cosine. So I'm going to say y equals negative cosine. And I'm going to put, notice that my goes from -3 to 3, so my amplitude is going to be 3, so I put the amplitude in there. And my period for this thing seems as though, before I started writing all over it, it looks like a whole period is happening between 0 and 1. So to get a period of 1, we know we take 2 pi divided by whatever here. So if I put a 2 pi there, I know that I'm going to have 2 pi divided by 2 pi gives me 1. And then I need to have an x. There is no shift left, right, so I'm going to put that right there. So that's my equation of that. Now on this one, let's take a look at coming up with an equation of that. It seems as though if I get the difference between that point and that point on the x value, I have 1.5 is this distance. So 1.5 is going to be that distance, and 3 is going to be that distance. So I know that I'm going to have a period of 3. We know that the normal period for sine is 2 pi divided by some b, and I want it to be a 3. So if I take and solve this, I end up with b equals 2 pi over 3. So when I make this, and let's start with this, it looks like a sine graph. So I'm going to say y equals the sine, and I know that my b is going to be 2 pi over 3. And then it doesn't look like I have any shift left, right, because I'm starting my period at 0 and I'm ending it somewhere over here. I'm going to guess 6 zeros, my guess. And I think I'm right. I still need to know the amplitude of this thing. So since this value is going up to 4, I'm guessing that's going down to 4. So I'm going to have an amplitude of 4 in front of there. Okay? All right. And if there's questions on that, you'll bring them to class. Section 7.4. Section 7.4, commonly used, simple harmonic motion is commonly used to model positions over time for a pendulum and a frictionless spring mass system. One common quantity used in the harmonic motion is frequency or oscillation, and that's the reciprocal of your period. Remember, we had 2 pi over b. So on this, your oscillation or your harmonic motion, your period, your frequency is going to be b over 2 pi. And in this case, they're saying it's 1. But whatever your period is, you're going to do the reciprocal of it, and that's going to be your frequency. And the units of frequency is cycles per second. Now, a spring mass system, let me see if I can, if I take a spring and I put some weight on it and give it some motion, it's going to be a little bit tighter, and then when it bounces back, goes back down, then they're further away from each other. So you get that bouncing motion where the weight down there and then the weight up there, and then it pulls back down there. And over time, that'll go to its normal position. All right. So suppose that we have a spring mass system. Motion can be described by the equation using the trig stuff, where S is in feet and T is in seconds, with equilibrium being in the position S equals 0. So we want to take this and we want to, so I did a little math here and graphed it. So if S is equal to 4 cosine, I'm going to put it in Mr. Otto standard form. I know that to find my period, I'm going to take, because it's a cosine, 2 pi divided by the 2/3, which gives me 6 pi over 2, which is 3 pi. That's my period. And so if that's my period, then the frequency of this is going to be 1 over 3 pi. That's my frequency. And the amplitude is the number in front here, so my amplitude is going to be 4. When the mass is moving upward, well, I took the time to graph this. The mass is moving upward when it is increasing. So I'm going to say it is, let's look at my graph, from here to there, and from here to there. And so let's write that in nice notation here. I'm going to put it as from 3 pi over 2 to 3 pi, union 9 pi over 2 to 6 pi. And when is the mass moving downward? Well, that's when it's decreasing. So I'm going to go from 0 to this 3 pi over 2, and from 3 pi to 9 pi over 2 is when it's decreasing. So I'm going to put that in a nice form. So 0 to 3 pi over 2, union 3 pi to 9 pi over 2. Graph the corresponding velocity function on the same graph. So if I do the same graph of the velocity function, so if I take this, I'm going to end up with the same period is 2 pi divided by 2/3, which gives me, and my amplitude is just a little bit less, and it's flipped. So instead of the normal sine, well, this is a sine, the normal sine goes up first and then down. I'm going to go down and then up. And the period is the same thing. So I'm going to do 8/3 is 2 2/3. So I'm somewhere about there, and there is as high and as low as it's going to go. So let's put that value on there. So it's going to start here. It's going to go down to about there. It's going to go through there. It's going to go 2 2/3, about there. Go through there, down to its lowest 2 2/3, negative 2 2/3, 0, positive 2 2/3, and back to 0. So if I graph that, there is my velocity. And notice as the spring is going down, the velocity is negative. So the velocity is negative means it's going down. So